Okay, let's take a look at this example. This is a three-dimensional example now. It's different than the other two-dimensional examples. The mass of a 100 kilogram crate, which means it's 981 newtons. There. We draw the free body diagram. It'll be on the next slide here. And we'll use Cartesian vectors. Let's take a look at this diagram first, though. First of all, you'll notice the force in this direction is strictly aligned along the x-axis. So FAB, strictly aligned along the x-axis. FAC is going to equal, in the x direction, it would be its magnitude times the cosine of 120 degrees. That's the x component. The magnitude times the cosine of 135 degrees, which is the y component. And the magnitude, which will represent, this will be the magnitude, times the cosine of 60 degrees will be the z component. This is the only component. The magnitude times I hat is the only component. This FAB is the only component of the force between points A and B. D, on the other hand, has a direction of -1 in the on the x-axis, +2 on the y-axis, and +2 on the d-axis. And it will be axial to the rope. So we're going to have the magnitude, FAD, times the unit vector. That's going to equal the vector force. Okay. The magnitude, negative I hat, or excuse me, the direction, -1 in the x, 2 in the y, 2 in the z, square root on the bottom of 1 squared plus 2 squared plus 2 squared. -1 squared is the same as 1 squared, which is why I didn't write a negative sign here, by the way. This is the unit vector in the AD direction. The stuff I've enclosed in parentheses is the unit vector in the AD direction. Magnitude of the force, and then the vector force. Okay, let's go to the next slide. I think we've written down our ideas. Okay, here's our free body diagram. We can put everything we did before, transfer it down here. We can write equations, which I spoke out in words on the previous slide. Oops. Kind of drawing it wonky. There we go. I'm really wonky. I promise I'm not drunk. It's working with these pen tablets. It's kind of not easy sometimes. There we go. FC, FB, FD. Here's that unit vector. It's in square brackets here. Weight. Got to sum to 0. So we've got 3 equations, 3 unknowns, which we can solve. I personally like MATLAB, so I'm going to show the MATLAB code. Here is another way to express that equation. You can write it as a vector, which is what I did. matrices, linear algebra, 1, 0, 0. This is the matrix in MATLAB right here. 1, 0, 0, negative a half, negative 0.707. MATLAB automatically keeps 16 digits of accuracy. So even though it displays only 5. And let's see, last one, 0.5, 0.5. So that is, this is the multiplier of the magnitude of f sub b in the x direction, multiplier times the magnitude in the y, multiplier times the magnitude in the z. This would be fc, multiplier the magnitude of fc in the x direction, multiplier the magnitude of fc in the y direction, multiplier the magnitude of fc in the z direction. And then finally, minus 0.333, and I'm rounding this time, 0.667, 0.667. Once you've got the hang of MATLAB, how to enter the square brackets, the coefficients, 100, cosines of all the angles, which is what gives the second column. I'm actually entering it in rows. This will be the first row of everything in the square brackets, second row of everything in the square brackets, and then the third row of everything in the square brackets. Negative 122 divided by the norm of negative 122. Norm is the magnitude of the vector. Okay. The prime transposes the matrix, switches rows and columns. So our final result here is exactly this. Okay. And then the variables FB, FC, FD. This is expressing it like a matrix equation, a linear algebra equation, equals. FD is the only one, 981 newtons. And then 0, 0. Only the Z component has a non-zero component, the constant, has a non-zero constant force. And of course, these are what we're trying to find right here. Set up the matrix equations, recall your matrices, your linear algebra, to get it back. Once you've got it set up in MATLAB, I've got my matrix, I've got my W, which is right there, the weight. Then I can solve this matrix equation this way and get the answers. FC, negative 694, rounding. FB, FCD, let's see, what is it? BC, FB, 697. FB, first row. FC, second row. FD, third row. FB, 694. There we go. FC, this is FC now. Same as the book got. And FD. We'll swing that around. There. Same as the book got. And that concludes talking about chapter 3 of the Hibbeler textbook on equilibrium of a particle. Lots of practice. Lots of homework, lots of practice. So don't hesitate. You only learn by doing. So this tells you how to do, why you do. I'm giving some background as to the why. I gave you some background as to the procedure, And then I showed a few examples, a few pertinent examples. And then the rest is up to you to practice and learn. Okay, next video is on chapter 4.